Neuromuscular junction. This topic explains the neuromuscular junction and its role in movement of the body. In human beings, we know that movement is due to the coordination of the brain and the muscles. If we take a closer look at a muscle, we see it has some nerve endings on their surface. These are the ends of the motor neurons. A motor neuron has a cyton and an axon. An axon is insulated with a protective sheath known as a myelin sheath. But as the motor neuron splits into many terminal branches, it loses its myelin sheath. In the axon terminal, also called the terminal bouton of the motor neuron, we find structures known as synaptic vesicles. These vesicles contain the neurotransmitter acetylcholine. The muscle fiber is folded into grooves called post-junctional folds. Upon the arrival of an action potential at axon terminal, voltage-dependent calcium channels open and Ca2+ ions flow from the extracellular fluid into the motor neuron's cytosol. This causes neurotransmitter-containing vesicles to move towards the presynaptic membrane and fuse with it to release acetylcholine in the synaptic cleft. Acetylcholine diffuses across the synaptic cleft and binds to its receptor on the muscle, causing them to open. These activated receptors now allow sodium ions to flow inside the muscles and potassium ions to move out. The sodium ions moving in are more than the potassium ions moving out, producing local depolarization of the motor end plate, known as end plate potential. This depolarization spreads across the surface of the muscle fiber, which helps in the movement of that muscle.